Good afternoon, Year 10. Mr. Stevens here. Sorry I'm not there with you this afternoon. You should have Mrs. Finlay with you. She might go through these examples with you. Well, that's fine. I'm just putting this video here if you need to refer back to it. This is very similar to a lesson we did last week where we were looking at real-life context, practical applications of nonlinear relationships. So I'm just going to quickly go through a couple of examples for you, and then you will jump into some of these questions for yourself. Excuse me. Here's a typical question we might get. We've got an object projected vertically in the air. We're given a quadratic formula and a quadratic graph. The parabola is given to us. But we're asked an interesting question here. We're asked, for how long is the object at a height of 300 meters or more above the ground? So we're going to look over here on the y-axis of the graph and find a height of 300 meters here and look at how long does the parabola go above 300 meters. For this amount of time here, the parabola is above 300 meters. So we just need to find out how many seconds are there between here and here. So we're going to count from 6 up to 10. So the correct answer is 4 seconds. You can see a question like that didn't actually really ask you to use any of the stuff we've learned so far in this unit. You just kind of had to use a bit of reasoning and know a little bit about how to read a graph, which we all should by now. Here's another typical question asked about a parabola. Again, a ball being thrown. You're getting asked what is the maximum height reached by this ball. So again, you just have to read off the graph that the maximum height reached by the ball was 24 meters. Now, here's a slightly more difficult example that we might get asked where we have to actually engage with the formula a little bit. We're given an exponential function here. We're told that a population of bats can be modeled with this formula. And we're trying to find the number of years it takes for the population to be 18,000. Jack, the person in this question, has tried to see if 9 years is the right answer. So he's put 9 into the equation, and he's got 98,415, which is obviously a lot bigger than the 18,000 we were interested in. So this first question here, part 1, is asking us to try a time of 6 years and see what happens. So we're going to try t equals 6, and we're going to put that into the formula and type it into our calculator and see what we get. 5 times 3 to the power of 6. In my calculator, I get 3,645 when I do that. Now, our conclusion from this, Jack's original conclusion up here was that t equals 9 is too big. But now we have a number that's much smaller than the 18,000 we were looking for. So our conclusion is t equals 6 is too small. So we're going to try a larger number for t as we continue this guess and check method to find the number of years. So we're still using this equation, but we're going to try t equals, let's try 7. We type it into our calculator and we get 10,000. Still, let's keep going. We'll try it to the power of 8 and we get 32,000. So that means that at some point in the 8th year, we went over 18,000. Now, the question only asks us to find t to a whole number. So we're done there. We know that, therefore, in the 8th year, the population goes over 18,000. And, we could start trying 7.5, 7.4 to be a bit more accurate and get exactly when it goes over 18,000. But the question only asks us for t to a whole number. So we found that in between t equals 7 and t equals 8 is when we clear that 18,000 that we were asked about. You guys are going to have a go now at some very similar questions to these. There are 11 questions on this worksheet. They come from past HSCs, actually, past standard maths HSCs. So some of them will force you to think a little bit. Mrs. Finlay is going to be there to help you. You also have some work solutions at the bottom of this sheet, but I would encourage you to use them only after you've had a think about the question for yourself. Thanks, guys. I'll hopefully be there with you on Friday, where we will finish off this nonlinear B unit.